ASP.NET MVC, or Model View Controller, was introduced in 2009. It marked a pivotal step forward in web development. Unlike web forms, which was designed for rapid application development with abstractions like server-side controls and event-driven programming, ASP.NET MVC focused on empowering developers with greater control over the application's structure and HTML output. It was built on the principles of separation of concerns, testability, and adherence to web standards, addressing the shortcomings of web forms. Let's dive into the key concepts and features that define ASP.NET MVC. The Model View Controller, or MVC design pattern, divides an application into three interconnected components. First, the model. It represents the data and business logic of the application. Often, it maps directly to the database structure or a data layer but remains agnostic of the user interface. The model handles validation, state, and data processing. An example in a conceptual sense. Models manage the retrieval of customer data for an e-commerce site. Next, the view. It represents the user interface. The view is responsible for rendering the content as HTML or another format like JSON or XML for APIs. Views are kept dumb, meaning they should only focus on presentation and not contain application logic. Finally, the controller. It acts as the intermediary between models and views. The controller handles user input such as HTTP requests, processes it, often by interacting with models, and determines which view to return. Controllers ensure separation of concerns by delegating logic to models and focusing solely on handling requests and directing responses. Now let's talk about the benefits of MVC. First, separation of concerns. Each component has a clear role, making applications easier to understand, test, and maintain. Next, scalability, with logic modularized into different layers, scaling specific parts of the application becomes easier. And finally, testability. Business logic is decoupled from the UI, enabling unit testing for models and controllers. Routing was a major shift from web forms' reliance on physical file paths. In ASP.NET MVC, URL routing defined how incoming URLs map to controllers and actions, which are methods inside controllers. A central file was used to specify routes, allowing developers to create human-readable, SEO-friendly URLs, like instead of. Routes were flexible and could include parameters, such as. The benefits of routing were significant. It decoupled the URL structure from the physical file system, enabled clean, semantic, and customizable URLs for better SEO and user experience, and made RESTful API design simpler, as URLs could map to specific resources or actions. The Razor View engine was introduced as a more lightweight and expressive way to render dynamic HTML compared to web forms' ASPX files. It featured a clean syntax that blends C# code with HTML and used to embed C# expressions within the HTML. This minimized the boilerplate code required for rendering views. The benefits of the Razor View engine were clear. It improved the readability and maintainability of views, offered faster rendering compared to older engines, and provided more fine-grained control over the generated HTML, adhering to modern web standards. ASP.NET MVC encouraged the use of dependency injection, or DI, to manage dependencies between components. So, what is DI? It's a design pattern where objects are provided with their dependencies rather than creating them internally. IOC containers like Unity, Ninject, and Autofac could be integrated to manage the lifecycle and resolution of dependencies. The benefits of using DI and IOC were substantial. They reduced tight coupling between components, enhancing modularity and testability. This approach made unit testing easier since dependencies could be mocked or replaced. Action filters were a powerful feature in ASP.NET MVC that allowed developers to run custom logic before or after specific actions or controllers. Examples of built-in filters include which restricts access to authenticated or authorized users, which provides error handling logic for controllers and actions, and which caches the output of a specific action to improve performance. Developers could also create custom filters to handle cross-cutting concerns like logging, auditing, or input validation. ASP.NET MVC was inherently designed to support unit testing. Controllers and models were decoupled from views, making it easier to test them independently. Controllers returned data such as JSON or view models rather than HTML, which simplified the testing process. The framework also supported mocking dependencies, allowing isolation of components during testing. ASP.NET MVC made building RESTful APIs intuitive by mapping HTTP verbs like get, post, put, and delete to controller actions. Developers could return JSON or XML responses directly from actions using built-in serialization tools. These APIs were widely used in single-page applications and mobile apps. So, let's talk about security enhancements. ASP.NET MVC introduced several mechanisms to address common web vulnerabilities. First up, anti-forgery tokens. There's built-in support for preventing cross-site request forgery or CSRF attacks using informs. Next, input validation. It used data annotations to enforce server-side validation, which could also be mirrored on the client side. Plus, it automatically sanitized user input to prevent cross-site scripting, commonly known as XSS attacks, and finally, authentication and authorization. It integrated with ASP.NET Identity for managing user roles, claims, and authentication. It also supported OAuth and OpenID Connect for modern token-based authentication flows. Moving on to scalability and performance. First, the lightweight framework. It removed the view state and heavy abstractions of web forms, reducing page size and improving server performance. Then, there's asynchronous programming. This enabled developers to write non-blocking asynchronous code using async and await, improving scalability for I/O bound operations like database queries or API calls. Lastly, output caching. It allowed caching of frequently accessed data or pages to reduce server load. Shortcomings of ASP.NET MVC. There was a steep learning curve. Developers transitioning from web forms found the MVC pattern more complex, requiring an understanding of concepts like routing, dependency injection, and separation of concerns. Another issue was the lack of a built-in component model. It lacked the drag-and-drop UI design approach of web forms, making it less appealing for rapid application development. And lastly, there was overhead for simple applications. MVC was more suitable for medium to large-scale applications, and its architecture could feel over-engineered for smaller projects. Why ASP.NET MVC was revolutionary? There was a shift to modern web development. It emphasized clean HTML, RESTful APIs, and adherence to HTTP standards, aligning with the needs of modern web applications. It encouraged best practices by introducing architectural patterns and principles, like separation of concerns and dependency injection, which became standard in the industry. It also empowered developers by providing full control over the rendered output, catering to developers building highly customized user interfaces. Impact on the industry. ASP.NET MVC set a new standard for enterprise web development, encouraging developers to build applications that were maintainable, testable, and scalable. It also prepared the ecosystem for the shift toward client-side frameworks like Angular, React, and Vue, which rely heavily on APIs. How ASP.NET MVC influenced ASP.NET Core. While ASP.NET MVC was a significant improvement, it was tightly coupled to the .NET framework, making it less versatile for cross-platform development. The rise of cloud computing, containerization, and microservices demanded a leaner, more modular framework. These needs led to the development of ASP.NET Core, which combined the best of MVC with additional flexibility, performance, and cross-platform capabilities. Let me know if you're ready for an in-depth explanation of ASP.NET Core.